Okay, so this is going to be about confusing MCQs. I suggest before you start this video to actually go over chapter 8, which is the equilibrium concepts that were taught in chapter 8. Also, every time I post something, I post a question, please try to pause the video and actually try to work it out on your own. You might have a wrong idea. I might have given you a wrong idea during class as well. So please try to solve it on your own and then see where we have made a mistake or where you have made a mistake and see what kind of analysis you should have taken, okay? So our first question is from 2006 and it goes like this. At a total pressure of 1 atmosphere, dinitrogen tetroxide, which is N2O4, is 50% dissociated at a temperature of 60 Celsius according to the following equation. What is the value of the equilibrium constant for this reaction at 60 Celsius? Now, I suggest you pause the video and actually try to work it out on your own. Okay, so if you have paused the video and tried to work it out, you would have probably thought of several ways to solve it. You would have probably thought that at a total pressure of 1 atmosphere and a temperature of 60 Celsius, I can get the number of moles really easily. And from the number of moles, I can get Kp. And we could talk about that for a second. But to get the number of moles, you need the volume because PV is equal to nRT. And even if you have pressure and temperature, if you are missing volume, you can't use this equation. Okay? Remember that at 24 decimeter cube, if you are thinking of using it, at 24 decimeter cube, 1 mole occupies 24 decimeter cube at room temperature and pressure. You do have room pressure, but you don't have room temperature. So you can't use the 24, okay? Decimeter cube relationship. Okay. Now, we have an issue here. How to solve this question? First, think of Kp. Kp is the pressure, PnO2, the pressure of product times the stoichiometry ratio of the product over the pressure of reactant. So we know it's PnO2 to the power of 2 times Pn2O4. When I say PnO2, I mean the partial pressure of NO2. And this means that we have P total times XnO2. I know P total. It's 1 atmosphere. So can I say safely that PnO2 is equal to 1 times XnO2, which is equal to XnO2? I can. Alright, so at this stage you might be thinking, what is X? Okay, so X is the mole ratio. XA is equal to moles of A over total moles. Okay, we don't know moles of NO2. We don't know moles of N2O4. But we do know that 50% of nitrogen tetroxide is dissociated at equilibrium. What does that mean? I'm just going to write the definition of X mole in these. Hold on a second. Well, it means basically if we bring 1 mole of N2O4, half of it would split. So after it reaches equilibrium, we have 0 to begin with N2O4. We don't know anything. Nothing is told to us about N2O4. We're just told that we have dinitrogen tetroxide and 50% dissociated. Now this is 1 mole of N2O4 initially. You have 0 moles of NO2, okay? 1 mole, half of it splits. So half the mole splits. This is basically the change. So 1 minus half, we end up with half a mole. Okay. We end up with 0.5 mole of N2O4. This is just based on the question. They told us that 50% dissociated. I'm using 1 mole. You could use 2 moles. Let's see if we can see it with 2 moles. If we have 2 moles here, it's probably easier to draw 2 moles. If we have 2 moles, one of them would dissociate. So this is the 50% dissociation. The 50% dissociation means that you have 1 mole of N2O4 left in your system at equilibrium. Now, this is based on this equation, and it's based on this 50% dissociated. How many moles of NO2 is going to be produced if 1 mole of N2O4 was consumed? Because 1 mole of N2O4 makes 2 moles of NO2, we can say safely that 1 mole of N2O4 produces 2 moles of NO2. They split into 2 atoms, so let me draw that. So here we have 2 moles or 2 atoms of NO2. This is based on this idea, and this is based on this idea. Alright? So, just to recap, we have 1 mole N2O4 at equilibrium. I'm going to draw a red line around it. And we have 2 moles of NO2 at equilibrium. This makes XNO2 equal to 2 over 3. The 3, this one, comes from here. From 2 plus 1 is equal to 3. This is 2 and this is 1. And XNO2O4 would be equal to 1 over 3. Alright? And Kp, based on our initial guess, was 2 over 3 square over 1 over 3, which makes it 4 over 9 over 3. We know this one deletes this one. So we end up with 4 over 3. So that is our answer. We know Kp has a lot of issues, so our answer should be C. So thank you so much for listening. This is one MCQ. I'm going to add the others as I go along.